Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem solve d square plus 4d plus 3 into y equals to e power x sin x plus x into e power 3x. So firstly, let's find order and degree of the given differential equation. Identify the highest derivative here. D square is the highest derivative. So our order will be 2. And the highest power of the highest derivative is a degree. Degree is 1. Or just write the given differential equation as d square y plus 4dy plus 3y equals to RHS part. Right? We know that d is a differential operator. Then we can write d square as d square by dx square. Now, we can write the equation as d square y by dx square plus 4 into dy by dx plus 3y equals to e power x sin x plus x e power 3x. So here d square y by dx square is the highest derivative. Our order will be 2. And the highest power of the highest derivative is a degree. Degree is 1. Now coming to the problem. Given differential equation, d square plus 4d plus 3 into y equals to e power x sin x plus x e power 3x, which is an operator form. F of d into y equals to q, where f of d equals to d square plus 4d plus 3 and q equals to e power x sin x plus x e power 3x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function, yp is a particular integral. We'll find yc using the rules of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply put RHS equals to 0, then we'll get f of d into y equals to 0, which is a homogeneous equation of the given non-homogeneous equation. And we'll find yp using 1 by f of d into q. Right? Now, let's start with yc. We need to find complementary function using the auxiliary equation. The auxiliary equation of f of d to y equals to 0 is f of m equals to 0, where f of m equals to, we are having f of d square plus 4d plus 3, right? Let's replace the differential operator by m, so that we'll get f of m equals to m square plus 4m plus 3. Then our auxiliary equation becomes m square plus 4m plus 3 equals to 0. Now let's split 4m as 3m and m. You'll get m square plus 3m plus m plus 3 equals to 0. Now take m common from the first two terms. We'll get m times m plus 3. And next two terms remain the same. Right? Now take m plus 3 common. We'll get m plus 3 into m plus 1 equals to 0. Now equate each factor to 0. From m plus 3 equals to 0, we'll get m equals to minus 3. From m plus 1 equals to 0, we'll get m equals to minus 1. Right? So we'll get m equals to minus 3 and minus 1, which are real and distinct roots of our auxiliary equation. Therefore, m equals to minus 3 minus 1 are the roots of f of m equals to 0, our auxiliary equation, which are real and distinct, or we can call them as real and different. Now coming to complementary function, we know that when two roots say m1 and m2 are real and different, then our yc will be one constant into e power 1 root into x plus another constant into e power another root into x, right? Now our yc looks like c1 e power 1 constant into e power 1 root into x plus another constant into e power another root into x. Then yc equals to c1 e power minus 3x plus c2 e power minus x, right? Therefore, yc equals to c1 e power minus 3x plus c2 e power minus x, right? We got yc. Now let's find particular integral. We can find particular integral using 1 by f of d into q. We have f of d, d square plus 4d plus 3, and q is e power x sin x plus x e power 3x. We can write it as 1 by f of d square plus 4d plus 3 into first term of q plus 1 by f of d square plus 4d plus 3 into second term of q, right? Now, we can find each term separately. Let's find the first term. 1 by d square plus 4d plus 3 into e power x into sin x. So this is of 1 by f of d into e power ax into some v form, right? For v equals to some sin ax otherwise. Okay. Now compare e power x with e power ax for a equals to 1. We'll find d plus a, which is for a equals to 1, we'll get d plus a equals to d plus 1. Now, shift e power x towards left. Okay, that means outside 1 by f of d. By replacing this d by d plus 1. Simply, we'll shift e power ax in front of towards left, okay? Towards left by replacing differential operator by d plus 1 into v, right? Beside 1 by f of d towards left, we are going to shift e power ax by replacing d by d plus a. Okay, here you're having a, right? So we used to put a here, right? This is equals to e power x into 1 by, replace d by d plus 1, then we'll get d plus 1 whole square plus 4 into d plus 1 plus 3 into v sin x, right? This is equals to e power x into 1 by, expand d plus 1 whole square, d square plus 1 plus 2d plus 4d plus 4 into 1 4 plus 3 into sin x. Is equals to e power x into 1 by d square, 2d plus 4d is 6d, 1 plus 4 5, 5 plus 3 8 into sin x. So now this is of 1 by f of d into sin ax form, right? Now we'll use the procedure of 1 by f of t into sin ax to solve this hereafter. Now, just compare sin x with sin ax. Then for a equals to 1, we need to find d square, which is given by minus of a square, which is equals to minus. For a equals to 1, you'll get 1 square, which is equals to minus 1, right? Now, by replacing d square with minus 1 in the denominator must be non-zero. If you get 0, the term under brackets becomes 1 by 0 into sin x. Since 1 by 0 is undefined, so total term becomes undefined, right? So firstly, let's see what happens if we replace d square in the denominator. Okay, I'll just take the denominator part. D square plus 6d plus 8. Now I'll replace d square by minus 1 is equals to minus 1 plus 8 is 7 plus 6d, which is non-zero, right? So we can dare to replace d square by minus 1 here. Right? Replace d square by minus 1. Then this becomes e power x into 1 by minus 1 plus 6d plus 8 into sin x, right? Which is equals to e power x into 1 by minus 1 plus 8 is 7 plus 6d into sin x. See, in the denominator of this fraction we are having 7 plus 6d. If you replace this plus by minus, you'll get 7 minus 6d, right? So multiply and divide 7 minus 6d to this fraction, then we'll get 1 by 7 plus 6d into 7 minus 6d by 7 minus 6d into sin x, which is equals to e power x into 1 into 7 minus 6d is 7 minus 6d by 7 plus 6d into 7 minus 6d into sin x. This becomes e power x into 7 minus 6d by, see, the denominator is of a plus b into a minus b form, so we can write it as a square minus b square into sin x, which is equals to e power x into 7 minus 6d by 7 square 49 minus 6 square 36 into d square into sin x. Again, d square appears in the denominator. So what we have to do here? We have to see what happens if we replace d square by minus 1 in the denominator. The denominator must be non-zero. (49) minus 36 d square is our denominator, right? So we'll replace d square by minus 1. We'll get 49 plus 36. 9 plus 6, 15. 3 plus 4, 7. 7 plus 1, 8. 85. Which is non-zero. So we can replace d square. Replace d square, which is equals to minus of a square, which is equals to minus 1, right? Now this becomes e power x into 7 minus 6d by 49 minus 36 into minus 1 into sin x, which is equals to e power x into 7 minus 6d by 49 plus 36 into sin x. which is equals to e power x into 7 minus 6d by 49 plus 36 is 85 into sin x. Now we can write this as e power x into 1 by 85 into 7 minus 6d into sin x, which is equals to e power x by 85 into 7 sin x minus 6d sin x. We know that d is a differential operator. In the next step, we need to find derivative of sin x with respect to x is equals to e power x by 85 into 7 sin x minus 6 into derivative of sin x with respect to x. So this becomes e power x by 85 into 7 sin x minus 6 into derivative of sin x is cos x. Therefore, 1 by d square plus 4d plus 3 into e power x sin x equals to e power x by 85 into 7 sin x minus 6 cos x. Now let's find the second term of yb. 1 by f of d into x e power 3x. And this is also of 1 by f of d into some v into e power ax form. For a equals to 3, we need to find d plus a. For a equals to 3, we'll get d plus 3. Now, shift e power 3x towards left by replacing d by d plus 3. Then we'll get d plus 3 whole square plus 4 into d plus 3 plus 3 into x is equals to e power 3x into 1 by expand d plus 3 whole square, which is d square plus 3 square 9 plus 3 to the 6d plus 4d plus 4 3s are 12 plus 3 into x, which is equals to e power 3x into 1 by d square plus 6d plus 4d is 10d plus 12 plus 3 is 15. 15 plus 9 is 24 into x. Now, this is of some 1 by function of d into x power k form, right? 1 by some function of d into x power k or say x power n form, right? Or we know that we have this form, right? Some x power k or x power n, 1 by f of d into x power n. So this is of this form. Now what we'll do is, here the denominator is in descending order form. So we'll write this in ascending form, and later we'll take the lowest degree term common from all these three terms. Okay, is equals to e power 3x into 1 by, I'm going to write the denominator in ascending form, 24 plus 10d plus d square into x. Now let's take 24 common from all the terms. But in the second and third term we don't have any 24. So what we'll do is, we'll just multiply and divide 24 to the last two terms. Right? Now it will be easy to take 24 common from the denominator, from the terms of denominator otherwise. This becomes e power 3x into 1 by 24 into 1 plus 10d plus d square by 24 into x, right, is equals to e power 3x into, we can split this total fraction as 1 by 24 into 1 by 1 plus 10d plus d square by 24, okay, into x. Now we can write this as e power 3x into 1 by 24 is e power 3x by 24 into, see here the second fraction is of 1 by 1 plus x form, right? 1 by 1 plus x form, we can write it as 1 plus x whole inverse for x equals to 10d plus d square by 24. Okay, we are going to write 1 by 1 plus x as 1 plus x whole inverse into x. Now we need to expand this using 1 plus x whole inverse, binomial series expansion. 1 minus x plus x square minus x cube plus so on. So before going to expansion, let's find the derivatives of x. Derivative of x is 1. D square of x is derivative of x, which is equals to derivative of, we have the value of derivative of x which is 1, and we know that derivative of constant is 0, right? So d square of x value is 0. Likewise, we'll get d cube of x equals to 0 and so on, which means that d power k of x is 0 for k equals to 2, 3 and so on, right? So by keeping this in mind, we'll expand 1 plus x whole inverse using formula 1 plus x whole inverse equals to 1 minus x plus x square minus x cube plus so on. Let's expand 1 plus 10d plus d square by 24 whole inverse, which is equals to 1 minus 10d plus d square by 24 plus 10d plus d square by 24 whole square minus plus and so on. We know that derivative d squares of x is 0, d cube of x is 0 and higher derivatives from d square is 0, right? Higher derivatives of x from d square is 0. So we'll get derivative value till 10d, right? And it's clear that the higher derivatives from here will become 0. What I mean is the higher derivatives of x from here becomes 0. See here you are having 10d, and if you expand 10d plus d square whole square, we'll get 10 square d square plus d square whole square plus 2 times 20 d into d square, right? We are having d square, d power 4 and d cube, which are higher derivatives, and we know that the higher derivatives from d square, d cube, so on of x is 0. So we'll neglect higher derivatives from here and we'll take only the first two terms, right? Now coming to this becomes e power 3x by 24 into, expansion of this is 1 minus, we are going to take only the first two terms, right? We know the reason behind this. 10d plus d square by 24 into x, right? Since d power k of x is 0 for k equals to 2, 3 and so on, so neglect higher derivatives from d square, d cube and so on, right? So this equals to e power 3x by 24 into 1 minus 1 by 24 into 10d plus d square into x. This becomes e power 3x by 24 into 1 into x minus 1 by 24 into 10d is 10 minus 1 by 24 into 10 is minus 10 by 24 into d of x, right? Minus into plus minus 1 by 24 into d square is 1 by 24 d square of x. Is equals to e power 3x by 24 into x minus 10 by 24 into, we have the value of derivative of x which is 1, minus 1 by 24 into, we know that d square of x is 0, so put 0, is equals to e power 3x by 24 into x minus 10 by 24. 2 5s are 10, 2 12s are 24. This is equals to e power 3x by 24 into x minus 5 by 12. Therefore, 1 by f of d into x e power 3x is e power 3x by 24 into x minus 5 by 12. Now we can replace the results obtained from the two terms in yp. Yp becomes, result obtained from the first term is e power x by 85 into 7 sin x minus 6 cos x, right? And result obtained from the second term is plus e power 3x by 24 into x minus 5 by 12. Now we can write the general solution because we got yc and yp. The general solution is given by y equals to yc plus yp. Then y equals to yc, we have c1 e power minus 3x plus c2 e power minus x and yp plus e power x by 85 into 7 sin x minus 6 cos x plus e power 3x by 24 into x minus 5 by 12. This completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.